8th graders, pretty easy little lesson for you guys today. The only reason there's a video for this is for the notes that I'm going to have you guys add to your notebook. So we're going to go ahead and jump right in. Okay, first activity for you guys is, of course, like I said, your notebook. You're going to open up OneNote, and then to your magnetism page of your magnetism section, you're going to add the notes on the next page. There's 2 things you guys need to add, and I'm just going to run through those really quickly with you. So first page you guys need to add is this one on magnetism. So these should be some fairly familiar concepts with the exception of electromagnets we haven't talked about yet. So first and foremost, magnetic force is the motion of electric charge or electrons resulting in repulsive with like charges or attractive with opposite charges forces between objects. So with magnetism, that is a force, okay? And that force can either be attractive, kind of like gravity where it pulls you in, or it can be repulsive and it can push you away. Okay, so again, that little invisible field outside kind of represents the force that can be exerted on an object, whether it either pulls an object in or it pushes an object away. Okay, obviously you guys know by now that this force can act over a distance, so you do not need 2 objects to be touching each other for this force to be exerted. You guys can just have them within the magnetic field. So if there's an object that's magnetic within the magnetic field of a magnet, okay, then it will be able to exert the force on that object. Okay, you guys should also know about the poles of a magnet. So that's where we're going to see the regions where the charge is the strongest. And as you guys know, there's a north pole and a south pole for a magnet. Okay. Magnetic fields are the invisible fields surrounding the magnets and exerting force. And again, that magnetic field is strongest near the pole. So if we're looking at where we have the most attractive or repulsive force, it's near the ends of our magnet, not near the middle, okay? And that has to do with how the electrons arrange themselves inside of the magnet. Okay, last but not least, electromagnets. We're going to learn about here in the next couple weeks. Basically, if we have something like a nail, okay, a nail isn't magnetic. We can't stick up a piece of artwork on our fridge using a nail unless we were to pound that nail in, okay, but it doesn't work the same way as a magnet does, okay. However, if we take a magnet near a nail, we can make that nail act magnetic, okay, but without a magnet, that nail in and of itself is not a magnet, okay, but with electromagnets, we can take a magnetic material like a magnet that isn't magnetic, and we can run electricity around it, and because of that, the way that electricity interacts with that magnetic material, okay, it can turn that nail into a magnet. So we're going to be building electromagnets here to kind of finish up this unit. So just to kind of go over your definition you guys have there. Electromagnets are where you see a coil of current-carrying wire wrapped around a piece of magnetic material, and that's going to produce a strong magnetic field for that magnetic material. So again, a nail is not a magnet, it is magnetic material. And if we run electrical wire around it and run a current through that wire, we can turn that magnetic material or that nail into a magnet where it picks up other pieces of magnetic material. In the case of what we'll do in a class like paper clips. Okay, this one you guys will see, this little picture here, you guys will also add right below these notes. You guys see a magnet with your north and your south poles, and then what you guys see are these little field lines. This should be fairly familiar to you guys. We learned kind of about these field lines and what they look like, their little pattern that they have in the magnetism lab. But what we see with field lines or the magnetic field is the field begins at the north pole and extends to the south pole. So we always see these lines connecting the north to south pole. The other thing that we explored in that magnetism lab is how 2 magnets interact, whether they attract or repel. If you guys have 2 attractive 2 attractive magnets, you guys would see those magnetic field lines running from the north of one magnet to the south of the other magnet if they're attracting. So they'd be going from one magnet to the other, okay? So from the north pole of one magnet to the south pole of the other. Okay, if they're repelling, you guys will see those magnetic field lines move away from each other from the north side and then connecting with their own self on the south side. So you guys won't see any of those magnetic field lines attracting or connecting those 2 magnets, okay? So that kind of concludes it for your note. The last part of this, you guys just have the critical juncture, right click and open up this link here, and then it'll take you guys into Amplify. You guys have, let's see here, 12 multiple choice and 2 short answers or written response. So go ahead, fill those out. Make sure you guys use the little purple bar down in the bottom to navigate. And eventually it'll say hand in. Once you guys have finished everything up, make sure you guys hand it in. And when you guys are done, you guys can go ahead and turn in this assignment. But the main thing I'm grading is your guys' critical juncture in Amplify. Try your hardest. You guys should know most of this material by now. Hope you guys are having a great day, and I'll talk to you soon.